Climate change is a problem we all know about. We've grown up with the impending doom that is the inevitability of melting ice, rising sea levels, and extreme weather changes. In the past 50 years, the average temperature of the Earth is rising at nearly twice the rate it was before. There are many natural ways that may explain why climate change has worsened, including volcanic eruptions emitting dust and gas, fluctuations within the strength of the sun, and even just the tilt of the Earth's axis. But the amount of greenhouse gases within our atmosphere is the highest it's been in the past 800,000 years, and the only explanation for that is human activity. The largest contributor from humans is the combustion of fossil fuels in the transport sector. The ubiquity of planes, trains, ships and cars, as well as the ease and cheapness with which we are able to travel wherever we want, whenever we want, has allowed for the rapid growth of CO2, a potent greenhouse gas, with the transport sector contributing around 25% of all carbon emissions. By now, you're probably familiar with the greenhouse gas effect, whereby certain gases in the atmosphere absorb and trap heat, resulting in an increase in the average global temperature. Increased wildfires, air pollution and food shortages are just some of the ways in which our planet could be affected. We could go on all day about the disastrous consequences of climate change, but why not focus on the brilliantly innovative solutions scientists around the globe are coming up with to tackle this seemingly insurmountable issue? One of the key problems with climate change is the melting of ice caps. Ice caps reflect sunlight into space, which enables them to remain cold. However, melting ice caps expose more seawater, which results in the absorption of more sunlight and heat. How could we possibly cool them back down again? Scientists have come up with a way of making the clouds over the ice brighter by spraying seawater into them. The salt in the seawater disperses within the clouds, leading to them reflecting the sunlight away from the ice and therefore keeping the atmosphere cold. Other scientists are looking into developing synthetic fuel, which utilises CO2. This not only removes CO2 from the atmosphere, but also creates an alternative to fossil fuels, which produce the greenhouse gases in the first place. Another avenue being explored is feeding bacteria with CO2 to produce biodegradable materials such as bioplastics. Both these processes actively remove CO2 from the atmosphere, generating a carbon-negative process. One simple solution would be to plant trees, since CO2 is absorbed naturally by trees via photosynthesis and is stored for decades. Expanding forests, however, are in direct competition with farmland and food production. This has led some to believe the solution lies in synthetic forests filled with artificial trees, which would require 500 times less space to capture the same amount of CO2. Any competition with farmland would further be eliminated, as a synthetic forest would not require farmable land. Students across the globe are also working hard to come up with solutions to reduce the harmful effects of climate change. As part of an international genetic engineering competition, our team at Exeter University are working on a process that produces calcium carbonate using genetically modified bacteria. The goal is to come up with a technique that emits less CO2 than other methods. This would be a suitable alternative to the traditional calcium carbonate production practices, which emit huge amounts of carbon dioxide. This process will take on the form of a 3D bioprinter that would have the potential to produce custom-printed calcium carbonate that can have multiple potential applications, including in environmental and clinical fields, such as building coral supports and personalised teeth. Other teams are concentrating on stopping the production of greenhouse gases altogether. A significant proportion of methane, a prevalent greenhouse gas, originates from cows. This led a team in Germany to work on a bacteria aptly named E. coli, which they genetically modified to sit in the cow's rumen and degrade methane before it could even enter the atmosphere, converting it into methanol, a substance which is harmless to cows. After the methanol is excreted, it can also be used as a source of energy, allowing what was once an environmentally harmful process to be converted into one which produces an eco-friendly biofuel. Clearly, synthetic biology has enormous potential, and may be key in helping to reduce the harmful effects of climate change. As individuals on a world stage governed by politics and powerful business interests, it's natural to think that being up against global corporations makes us powerless. Whereas reducing your carbon footprint and pursuing an eco-friendly lifestyle by cycling to work, turning off lights, being mindful of fast fashion, and even becoming a vegetarian are great first steps to protecting our environment, we are undoubtedly at our most powerful when we come together collectively. Putting pressure on governments and demanding change on a policy-making level is vital, as well as supporting scientific research and innovation.